Hello, family, friends, and loved ones. My name is Ishmael Nyame, and I am here once again to bring you another exciting moment of study. Um, this study is actually based on a particular area or question that has already been written as a BEC exam. Okay, and in this study or this video, we are going to take a look at this particular area that is a concrete or a more likely examination question, okay, a likelihood examination question. You know, most students and teachers are about the fact that we have some past questions, okay, appearing or resurfacing in any incoming BEC exams, okay? But it is not just about you having this idea and solving these past questions, but it is how best you understand the answers to the questions. So students, a lot of students purchase these books, okay, and take a look at the answers to the books and just put them or accumulate these answers into their head without any concrete or any vivid or best understanding. And as a result, they easily forget. And you and I can bear witness to this, that if you should forget the slightest or the little key fact or information from what you have accumulated in your head raw or in a raw form, then you will not be able to remember the other ones that should be following. Okay, so I believe that if there should be a correct or concrete understanding of why the answer is so, then the students will be able to have this information with them in their head all the time for a very long time. So I'm going to give you the reason why the answers are so that you understand, okay? And from what we can see here, our learning objectives are given. Our first learning objective is how to state the effect of substances on pH indicators. The second one, make observation from red and blue litmus papers. The next one, identify if yes or not a substance is acidic, okay, neutral, or alkaline, okay. Then the next one, identify if a substance, okay, identify a substance that undergoes neutralization reaction to produce salt and water. And the last one that we're taking a look at is writing a chemical equation for neutralization reaction, a balanced one, of course, a balanced one, of course. So we are going to satisfy these objectives here, considering this basic question over here. That is also a more likelihood question that students may be meeting. You know, it doesn't matter if it's it came or appeared in some few years ago. You know, there are mostly or there are some chief examiners reports that come after every examination telling the strengths and the weaknesses of students, okay? And most of the time, students are not able to just copy and complete simple tables on effects on litmus paper. So when chief examiners make such remarks, it means that it calls for another moment of testing the student again, whether their teachers are able to take them through a more comprehensive thought based on this topic. So let's start rolling. State the effect of the substance on the pH indicators. We need to understand what a pH indicator is, or what pH indicators are. We already understand that pH simply refers to the acidity, neutrality, or the alkalinity of a substance, as in whether a substance is an acid, a neutral substance, or an alkali substance. That is whether it is a base, okay? So that is what pH actually is about. And we understand pH means power of hydrogen, okay? So that will be for some discussion next time. And litmus papers, okay? Litmus papers are indicators, okay? So when we say pH indicators, we actually refers to some materials, okay? Whether liquid or solid materials like a paper form, okay, some materials that are able to tell, okay, are able to give an indication, give a sign, give an indication that this substance is a neutral substance. This substance is an alkali substance. This substance is an acidic substance. Okay, so any substance, whether liquid, gas, or solid, okay, that can be able to tell. That can be able to tell whether whether a particular substance is an acid, a base, or a neutral substance is a pH indicator. Is a pH indicator. So with the litmus papers, if a litmus paper can tell me whether a substance is an acid, a base, or a neutral substance, then the litmus paper is indicating the pH of the substance. Okay? If I have a litmus paper, you know litmus papers looks like this. If I have litmus paper and I have a beaker, and in the beaker I have water, and I dip a portion of the litmus paper into the water in the beaker, okay, there's going to be a sign, okay, a sign on the litmus paper that tells whether the water is an acid, the water is an alkaline, that is a base, or the water is neutral, okay. So if from the sign we are able to tell whether it's an acid, a base, or a neutral substance, it means that this litmus paper here is indicating the pH, okay. So the pH of the substance is always either acid, neutral, or a base. Okay, so any substance that is able to help you indicate whether another substance is an acid, a base, or a neutral substance is an indicator, is a pH indicator. Okay, so that's what pH indicators actually are, or that's what they mean. Okay, so anything that can tell whether a substance is an acid, a base, or a neutral substance, okay, is a pH indicator. So I believe we understand what pH indicators are. So we are going to complete or provide what we need to give to that objective there. So we have to state the effect of substances on pH indicators. Now from this table we have these substances, okay. We have these substances. So we have to tell the effect of these substances. Effect of substances. So effect of these substances, okay, on pH indicators like red litmus paper and blue litmus paper. Okay, so telling the effect simply means that if I should be having a blue litmus paper or red litmus paper in a lemon juice, okay, what is the lemon juice going to do to the red litmus paper? What is the lemon juice going to do to the blue litmus paper? If I have a blue litmus paper and I dip it into calcium hydroxide, what is the blue litmus paper going to do, okay, with this one? What effect, what action is this substance going to have on the blue litmus paper? What action is this going to have on the blue litmus paper? Likewise, the red one. If I have the red one in this, what effect, what action, what are we going to see happening to this paper when I have this in this, when I have it in this, and when I have it in this? So that is what you're going to take a look at. Now, substances have different effects, okay, on litmus papers. I mean, different substances have different effects on litmus papers. The way that an acid, the way or the manner or the effect that an acid will have on a red litmus paper is not the same thing that a blue litmus paper is going to have on another substance, okay? So what I'm trying to say is that if I have this one here to be an acid, okay, and I put this red litmus paper into this acid, the effect that the acid will have on the red litmus paper is not going to be the same as the effect that a particular substance, that is a different substance, I mean a substance that is not an acid, so something like calcium hydroxide, where it's a base, okay? So it's not going to be the same as the effect that this base will have on the red litmus paper. So in simple words, acids have effects on red litmus papers and blue litmus papers, which are not the same as the effects that a base will have on these same litmus papers. So the effects that acids have on litmus papers are different from the effect that bases have on litmus papers, and are different from the effects that neutral substances have on litmus papers. Okay, so please understand that for me. Okay, so with what we have here, lemon juice. Lemon juice is an acidic substance. It is not entirely an acid, but it is an acidic substance. Okay, we get the juice from the lemon, so lemon juice. Okay, lemon juice contains substances like water. So I am giving you the composition of lemon juice. Okay, so contains substances like water, contains some sugars, some glucose, okay, in it. They also contain some small amounts of amino acid, okay, so some amino acid inside it, and some substances, okay, that has some aromatic effect, okay, so some aromatic compounds, okay, so aromatic compounds, some aromatic compounds, okay, yeah. Then the last one, an organic acid, okay, and that should be the citric acid. Okay, so these are substances in lemon juice. So this one confirms that the lemon juice isn't entirely an acid, but it is acidic. So when we kind of say a substance is acidic, it means that that substance contains an acid. Okay, contains an acid. Then when we take a look at calcium hydroxide is entirely a base. Okay, then hydrochloric acid is entirely an acid. So if you should be comparing lemon juice to HCl, lemon juice isn't entirely an acid, but it is still acidic. But HCl is entirely an acid. Okay, you understand the reason why I'm giving you this explanation. Like I said, I am giving you the reason why certain answers are so or are such. Okay, so entirely not an acid, but entirely an acid. Okay, so now completing the table that we have over here. What I'm going to put in these spaces here are the colors that I'll be seeing on these litmus papers. So the colors are telling you whether the substance is neutral, a base, or an acid. Okay, so with that of red litmus papers, anytime you have a red litmus paper in an acid, the red litmus paper will still remain red, meaning that you don't see any different color from the red litmus paper, or you don't see the red litmus paper changing color, meaning that it maintains its red color. Okay, so that is the effect on the red litmus paper. Now let me use blue litmus paper on the same substance. Using blue litmus paper on this same lemon juice. When I put this blue litmus paper into this lemon juice, this time the blue litmus paper becomes red. So the question is, why is it that we have the blue litmus paper becoming red in this substance, but this red litmus paper didn't turn red in this substance? The explanation is that all acid turns litmus papers into red, whether red by its actual or own color or blue. So irrespective of the color of the litmus paper in an acid should be red. So whenever you have a litmus paper in an acid, the paper should appear or turn red. Okay, so that should explain the reason why we had the blue litmus paper becoming red. So acids always make litmus papers red. Okay, so the blue litmus paper turned red because the lemon juice is acidic. It contains an acid. Okay, so that's the reason why we have the answer here to be red. Okay, on observation. So over here you write litmus turns red. As simple as this. Okay, now in the case of the red litmus paper, because it is originally red, or it is already red, okay, you are not going to see anything different, because you are going to have red litmus papers always appearing red, provided the substance you have there is an acid. Okay, so the basic line here is that acids make litmus papers red. So because it is originally red, you still see that red color that it originally has or possesses. Okay, so you are not going to use the word turns or changes, because there is no change in color. Okay, so instead of saying red litmus paper turns red, it doesn't sound correct. Okay, you say litmus remains red. So you don't say red litmus paper, you don't say red litmus paper turns red, or litmus paper turns red, because it is originally red. It is already red. So it is not turning into another color. It is not changing into another color. So all that you say is that litmus remains red. Or better still, instead of using remains, you can say stay red. Okay, so litmus stay red. Litmus stay red. So you don't say litmus turn red, because it is already red. So when you say litmus turn red, it means that perhaps you had copied from somebody. Okay, and any experienced marker is going to realize that and penalize you for it. So make sure even the way that you, or the manner that you present your answers, are done in the rightful way. That is why, of course, I am here for you. If you are enjoying the lesson, please like the video, then share it among your friends, then hit on the notification button, okay, so that you can receive any other new video that pops up or comes, okay, so as you don't get to miss them or they missing you, okay. So this is what we have. These are the reactions or the effects, okay, that these substances are going to have on these papers. Okay, say lemon juice turns blue litmus paper into red, but you don't say turns red litmus paper into red. It doesn't make sense in that part. So lemon juice turns blue litmus paper into red. So litmus turn red. Lemon juice, okay, will make the red litmus paper red. But because it is already red, you simply say litmus remains red, or litmus stay red. Okay? Now, these actions or these indications here means that what we have here, okay, is acidic. So the conclusion you are making is just about whether the substance you have is an acid, a base, or a neutral substance. Okay, so from what we have here, it means that our substance there is what? An acid. So I simply write here acid. That's all. As simple as that. As simple as that. Then we come to the next one. Substance 2, or calcium hydroxide. Okay, calcium hydroxide is a base. Okay, so that means that you should also get to know your compounds very well. Okay, because if I had known that calcium hydroxide is an acid, then my observations and conclusion is going to be wrong. Okay, just because I couldn't identify the kind of pH this compound is. Okay, so make sure you get to know that as well. So when you get to see a base, you should acknowledge a base. When you get to see an acid, you should know what an acid is. When you get to see a neutral substance, you should know what a neutral substance is. Okay, all right. Actually, I can give you a clue that anytime you have a compound, okay, that is made of a metal like calcium, like sodium, like potassium, with hydroxide ion, you'll be having a base. Okay, so that is a base. Or you have any of this with an oxide ion, you'll be having a base. Okay, so keep that in mind. At least I've helped you with that. So make sure you don't miss the next video so that you get to understand certain things about how to identify a substance, as in it is a base, an acid, or a neutral. Then you'll be able to correctly fill up the spaces that you may be provided with. Okay, so what I have here is a base. Because it is a base, it is going to have a blue color effect, okay, on litmus papers. In other words, we are always going to have litmus papers appearing blue in a base substance. So far as the substance is a base, the litmus paper will become blue or will be seen to be blue. Okay, so irrespective of the color of the paper, whether it is red or blue, it should be seen blue in the base. Like in acid, whether the paper is red or blue, it should be seen red in an acid. Whether the paper is red or blue, it should be seen red in an acid. And whether the paper is red or blue, it should be seen as what? Blue in a base. Whether it is red or blue, it should be seen as blue in a base. So base always gives the blue effect. Acid always gives the red effect. Base always gives the blue indication. Acid always gives the red indication. Okay, so red litmus in a base. I guess you should know that we are going to have the red litmus paper turning blue. So litmus turns blue. Bases make litmus blue. Whether red litmus paper or blue litmus paper, it should be blue. So because it is a base and the litmus paper is red, now the red has become blue. Now what I have here is already blue. Okay, so like something here. Okay, what I have here is already blue, like something here. It's already red. Red in an acid remains red. Now what I have here is already blue. Blue in a base remains blue or stay blue. Okay, so litmus stays blue. Okay, litmus stays blue. And what I have here, of course, is a base. So I simply write here base. Okay, and the last one, HCl, is an acid. Okay, either organic acid or inorganic acid. And because it's an acid, all acids make litmus red, irrespective of the color of the litmus paper. So this color here is already red. So that means that the red litmus paper stays red or remains red. So litmus stays red. Then it is blue here. So we say litmus turns red. As simple as that. So in simple words, get to know that acids make litmus papers red, irrespective of the color. Whether it is blue or it is red litmus paper, it should be seen to be red when the paper is dipped, okay, or immersed into the acidic substance. Then bases make litmus papers blue, irrespective of the litmus paper owns color. Okay, so if the litmus paper is dipped into the substance and the substance is blue, the litmus paper should be seen appearing blue. Okay, so because it's an acid, I simply write here acid. So now we have successfully filled the table. Okay, we have been able to copy and complete the table. Okay, so from the observations, we have been able to state the effect of these substances on the pH indicators, like what? The red litmus paper and the blue litmus paper. Now the next thing is to make the observation, and of course we have done that. The following is to identify if the substance is acidic, neutral, or alkaline, and of course we have done that too. So from here we know it is acidic. So you can also write acidic if you don't want to use the word acid. Okay, you can write alkaline if you don't use the word base. okay, then acid as well. As simple as that. So we have been able to satisfy this one, this, and this one too. Now the next thing is to identify substances here, okay, that undergoes neutralization reaction to produce salt and water. To produce salt and water. I explained to you that lemon juice is not entirely an acid, okay? It is an acidic substance, but not entirely an acid. And I gave you the constituents of lemon juice, okay? So that means that if you should be reacting lemon juice, okay, with calcium hydroxide, where is a base, you wouldn't be having a pure neutralization reaction. For the reason that, or because the lemon juice is not a pure acid. So the lemon juice is not a pure acid. It is an impure acid because of the involvement or the inclusion of water, glucose, and the other compounds, the aromatic compounds. Okay, you cannot have lemon juice reacting with a base to give you a pure neutralization reaction. No, it doesn't work that way. So for you to have a neutralization reaction, you need a pure acid and a pure base. So a neutralization reaction is an acid that occurs between an acid and a base to produce salt and water. In the definition, there was nothing mentioned like pure acid. Yes, there was nothing mentioned like pure acid, but it is better to understand, it is good to understand that if the acid isn't pure, it is not going to have reproducing a pure neutralization reaction. Okay, so for we to identify the substances here that will be able to undergo neutralization reaction, we shouldn't select lemon juice with calcium hydroxide here to form neutralization reaction. Okay, so we shouldn't go for that selection. Rather, we should go for HCl, which is a pure hydrochloric acid. So we have to react hydrochloric acid with calcium hydroxide here to have our salt and water produced, or to have our occurrence of neutralization reaction. Okay, so somebody might be thinking of lemon juice because lemon juice is identified as an acid or acidic. Okay, so you don't do that. So neglect lemon juice and go for calcium hydroxide and HCl. Okay, so the substances that will undergo neutralization reaction is calcium hydroxide and hydrochloric acid. Okay, so I'm going to write that over here. So calcium hydroxide, then hydrochloric acid. So calcium hydroxide and hydrochloric acid. So these are the two substances here, okay, that will react to produce salt and water. Okay, that will react to produce salt and water. So do not have your choice of acid, okay, to be lemon juice instead of hydrochloric acid. Okay, and the reason is that lemon juice is not a pure acid, so we don't use that for our reaction. Then we are to write a balanced chemical equation for this reaction. So hydrochloric acid as HCl plus calcium hydroxide as CaOH2. Okay, so that is what we have now. Now this acid here is going to combine with the base we have over here to form salt and water. Now in the chemical combination, we are going to have the hydrogen here, okay, to combine with what? The hydroxyl here. Then you have the metal here, that is the calcium, to combine with the chloride over here. Okay, now the chemical combination of the calcium in the base here, which is calcium, okay, so calcium here with chloride here is going to give us calcium chloride. Okay, so we have calcium chloride as our what? Salt. So calcium chloride as salt, all right? The metal in the base, which is calcium, chemically combined to the chloride in the acid, which is chlorine or chloride, okay? So calcium chloride as our salt. Then, like I said initially, having our H here to combine with the hydroxyl in the base over here, okay? So the proton H here with the hydroxyl is going to give us H2O, okay, as our water, right? So we have successfully produced salt and water, okay, out of HCl and calcium hydroxide. So now let's balance it. Of course, it is not balanced, so let's balance it. In the balancing of this equation, because this topic is not about balancing of chemical equations, I'm going to be brief. Okay, so make sure you don't miss our incoming video so that you understand the one that we present to you on balancing of chemical equation. Now, in our balancing, we look at this compound here and we see hydrogen to be 1. So it's 1. Then over here, it is 2. Okay, so it is actually 1 in the bracket, but because of the 2 outside, it is 2. Okay, that is because the 2 here is multiplying the 1 in the bracket. So 2 with the 1, 2 times 1 giving us the 2. So these 2 plus the 1 we have, they're giving us 3 of hydrogen. Now when we come here, we have 2 of hydrogen, and 3 is not equal to 2, so we have to balance hydrogen. So in the balancing, we can think of, or we can preferably make it 4 and 4. Okay, so making it 4 and 4 in summation, we already have 2 here. So we just make the H here 2. So that we add the 2 of this H to this 2 here. Okay, then we have 4. Then we add 2 to this one. Okay, then we have 4. Now when I say add, I do not necessarily mean add as in arithmetic addition. Okay, something like writing it. Okay, so when I put 2 here, now H here is 2. H here is 2, now it is 4. When I put 2 here, it is already 2. This 2 is multiplying this one, so it's 4. So hydrogen is balanced. Then chlorine has now become 2 because of this 2 over here. That is because the 2 here is multiplying the 1 we have, it's making chlorine 2. Then when we come here, we have chlorine to be 2, so that means that chlorine is already balanced in the course of balancing hydrogen in the chemical equation. Then we come to calcium. Calcium is 1 here, calcium is also 1 here. So we have 1 and 1 at both sides of the chemical equation for calcium. And the last one, which is oxygen, okay, oxygen is 1, but because it is 2 here outside the bracket, oxygen is 2. Then from what we have here, it is 1, but because of the 2 here, oxygen is also 2. So oxygen is balanced. Every single chemical element in here or atom in here is balanced. So the whole equation is balanced. So we have our balanced chemical equation. I believe I have brought to you a more comprehensive and concrete lesson or study, okay, on some of our dependable or questions, basic questions that we should be looking forward to. I believe from now onwards, you will be able to understand better all of these and why their answers are as such. If you like the video, hit on the thumbs up button, then share it among your friends so that they can also benefit what you have benefited from. Hit the comment section or button, then hit on the all bell so that you can receive all the following or incoming videos. Thank you so much for staying with us, and I'm glad you understand this. My name is Ishmael Nyame, and bye-bye. See you later.